Hi, welcome back to the channel. Today we're going to be going over a practice interview preparation kit question from HackRank, string manipulation, and it's going to be checking if two strings are an anagram and how many letters you need to delete from each to make that happen. So this is going to be done in Python, but you can do this with any language. The basic approach is similar. So the question is as follows. You have two strings, A and B. Each one is a series of lowercase English letters, and you need to compare and find out how many of each string you need to delete in order to make them anagrams. And anagrams, as it states in the question, are strings that both contain the exact same letters in the exact same frequency. So for example, two A's, it doesn't matter how they're scrambled with a B. So for example, BACDC and DCBAC are anagrams, but these two are not. So that's basically the question, and the constraints are that the size of the strings can be anywhere between 1 to 10 to the 4 long. You can review all this for yourself when you do the question, but we're going to go skip right to the coding. So there's a couple ways you can approach this. A novice might immediately think, well, let's just check every character in each string and check if it's in the other one. And then if it's not, then you can delete it. And then, that A is going to take quadratic time, potentially, big O notation n squared, or is prone to mistakes because what if you have the same letter twice? But in one you only have it once, so then you got to keep track of counters, and it's a little bit of a mess, and it's also not very efficient. So we're going to skip that approach. The second approach you might know if you're working with Python is the string count function, which is just can be written something like this, like abc dot count. So count of count A, for example, is equal to abc.count of A. So you can do something like that. But in the case, and then obviously loop through 1 through A to Z. In this case, we're not going to use that approach because while it might be faster and easier to code than the first example, it's still not very efficient in the sense that the count, in order to find how many times A occurs, needs to go through this entire sequence. And when we're checking, for example, how many times A happens, or B, or C, you're basically duplicating the same search 26 times. So there's a lot of wasted comparisons that we don't really need. You can try this out on your own, but the general approach with this would be in a for loop, checking every single letter, using this count to find out how many of that specific letter are in each string, and then subtracting the two, and then adding that all up for all the letters in the alphabet. We're not going to do that approach because, like I said, it's not the most efficient. We're going to do one that's a little bit more efficient. So let's go ahead and start that. So we're going to need two dictionaries. So we're going to say init dictionaries. So that's going to be a dictionary is equal to dictionary, whoops, and then b dict. So those are dictionaries. We're going to initialize them with empty values. So we're going to go ahead and say for letter in A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, Y, X, and Z, or Z. So we're going to go ahead and for every letter, we're going to say a dictionary is of that letter. So the key is going to be equal to 0. So we're just going to initialize that. We're going to do the exact same thing for the second dictionary, except it's going to be B. So there might be more efficient ways, but this is just to illustrate the point. Then we're going to go ahead and just iterate over each string. So we're going to say a dictionary of that letter, and then plus equals 1. So this logic is fairly straightforward, but again, count of each letter in the string. And then we're going to do the same thing for B. Let's just make sure that's indented properly. And now we have the count for A and we count for B, and then we just repeat the same check. So for every letter in A, B, C, D, E, F, G, all the way through Z or Z, we're going to then check difference in each letter and add to count of deletions. Now at this point you might be noticing that this is almost similar to the second approach that I mentioned, except that instead of duplicating, we go through each letter only once, each letter in each string only once, and add that to the dictionary for that letter. So for example, in A, if we have A, B, C, for the letter A, we add that to the dictionary for the key value A only once. We don't have to keep checking that letter. So it's one search. So you just perform n operations and n is the size of your string of A. So it's more efficient because we're not duplicating that check. And obviously for a short string it doesn't matter, but if you're starting to get to multiple comparisons and you say you had 10,000 elements or 100,000 or 10 million or billion, whatever, it might be a lot slower to check those things. So let's go ahead and say that for each letter, we say A dictionary of that letter minus B dictionary of that letter, right? Now we're going to go ahead and say, let's get the absolute value of that. And I'm going kind of backwards. And then let's say, let's initialize actually the count. Count del is equal to 0 because we haven't deleted anything. And we're going to say count del plus equals the absolute value of that. And then obviously at the end of our function, we're going to return count of del. Now we're going to go ahead and ignore in this, for example, case any base cases. For example, if it's less than 1 or larger than 10,000, checks like that, those you should do at the very beginning up here, because you might not have a perfect string input. You might not have something, so we tried to run this previously at the very beginning. So see, there you go, submit code. We're just going to run through all the test cases. So perfect, we run through 15 test cases, all of them passed. Congrats, we've solved the problem. But the importance of doing those checks at the beginning are, for example, if A, so length of A is greater than 10,000, or length of B is greater than 10,000, return 0. We're just not going to bother with this. And let's do the same thing for if the length is less than 1. Because again, we don't really want to deal with those scenarios, so we're just going to go ahead and ignore them like so. So now we can run the code again. Now, as you can see, there's multiple ways to approach the question. There's obviously many different ways you could code this question. There might be even more efficient ways than what I've implemented. But you can see that the general approach is to maybe start simple, start with a couple of ideas and refine them over different iterations. So I proposed 3 solutions, and we tried to take the less optimized version and then improve on it. So again, if you're a beginner or even intermediate, even though this question is easy in difficulty, it highlights that that when you approach a problem, there's always a consideration to be made with the size of the data, what can be done to improve it, time complexity, space complexity, things like that, that when your application might scale up, might actually impact your code and your approach to those questions. And so in an interview, they might ask you, well, you know, execution time is big O notation of n squared. What can you do to improve this? Where can you improve on time or space complexity? And so, as you can see in this process, we mentioned multiple steps to increase and improve efficiency, and you should do similar things when you approach questions like these, even though they are only easy difficulty level on HackERRANK. And with that said, if you have any questions, or if you'd like me to answer a different question on HackERRANk, or if you have a more efficient solution to this particular problem, feel free to drop a comment in the comment section below. Please subscribe, please throw a like on this video, and I'll continue to make more content for you guys.